Thomas with RF Elements, and today's Inside Wireless episode is about network coverage. Before we go into the topic, like, comment, and consider subscribing to our channel. When planning a wireless network, there are many online and offline tools that help you visualize how the network coverage will look like. Some of these tools use a section of a circle corresponding to the antenna beam width in place of the expected coverage. The truth is, beam width is not coverage. Beam width defines the angular width of antenna main lobe -3 or -6 dB below the maximum gain. Despite the beam width and coverage being connected, it is a huge oversimplification to consider them the same thing. While the knowledge of the beam width is helpful when aligning point-to-point links or deciding what application is an antenna good for, it will definitely lead to misleading results if you rely on it for coverage prediction. The truth is, there are a handful of parameters that are needed for precise coverage prediction. Antenna radiation pattern, its gain, radio output power, and accurate map data. With these, it is possible to obtain what coverage truly is, a continuous image of signal strength in an area. A good example of coverage is a flashlight pointed at a surface. It is intuitively clear that the spotlight on the ground is the coverage, and the flashlight can be viewed as an antenna radiating visible light, which is also an electromagnetic wave, just like RF waves, except at much higher frequencies. Besides the light, the EM waves are invisible to human eye, making the visualization of RF coverage more difficult. What we can do though is to visualize RF coverage using a pseudocolor. Assigning the strongest signal certain color, and the weaker the signal gets, the more transparent it becomes. Here we show the coverage using a 30-degree symmetrical horn. The dashed line indicates the -6 dB beam width. It's obvious that the covered area spans well beyond the beam width angle. This is because the coverage is a projection of the whole radiation pattern onto a surface. While this visualization is the closest thing to reality, it is not practical. With no clear coverage edges and increasing transparency of one color, it is hard to read precise values of the signal strength directly from the image. We can improve this by using multiple colors. This is the same image, but using 5 colors. Now, it is way easier to quickly estimate the RSSI level at any point. And we can go even further. If we know the noise floor level and the width of the radio channel, we can plot MCS isosurfaces. Here, each color corresponds to a range of achievable MCS rates you may know from your radio interfaces. This way, the borders between the areas are very clear and provide a quick and easy reference while designing your next link or optimizing the coverage of an existing one. The RF Elements link calculator shows you the coverage you can achieve with horn sector antennas and optimize the downtilt and network coverage. If you find our videos useful, like, leave a comment, and consider subscribing to our channel, and we'll notify you whenever a new episode is out.